All right, we have a question on vectors to deal with. Question says, calculate the magnitude and the direction of the resultant of the vectors below. So we have, sorry, this is Newton. We have 1, 2, 3, 4, 5 vectors acting at a point with their respective angles from the point of action. Now, before we proceed, we need to establish some conventions that will enable us to be able to get this accurately. All right, let's dive in. Now, the first convention is that the angles which we must be using, our angle which we must be using must be the angle which the force is making with the horizontal line. This horizontal line is our reference point. So all the angles must be done with respect to the angles they are making with the horizontal. Now, the first angle here is 20 Newton. 20 Newton is at angle of 40 degrees with this horizontal. It's on this horizontal line. So for 20, we're using 40 degrees for the angle. Angle we're using is 40 degrees, which is this. Now for 12 Newton, the angle it makes is 50, so we're using 50 degrees. Now for this 15 Newton, despite the fact that we have angle 30 here, the angle 30 here is not the angle it makes with the horizontal, it is not. So in that case, we must get the angle it makes with the horizontal, which is this particular angle. Now, how do we get this? To get this, we know that the whole of this, the angle between the east and the north and the south is 90 degrees. So this angle should automatically be 90 minus 30, which is equals to 60 degrees. So the angle for 30 will be 15 will be 60 degrees. Sorry, we forgot this. For the force 10 Newton, force 10 Newton is directly on the horizontal line. So in that case, it is exactly parallel to the horizontal. In that case, there is no angle. That is the angle between 10 Newton force and the horizontal line is 0. So we make use of 0 degree for particular force. Lastly, we have angle 60. Lastly, we have for 16 Newton. 16 Newton is purely perpendicular to the horizontal direction. So it is purely normal, angle 90 to the horizontal. So in that case, the angle here is 90. So in a nutshell, we'll be using 90 degrees to resolve this particular force. So 90 degrees for this. Now let's dive in. Now, second convention we look at is the directional convention. Now, all angles now must be resolved in two directions: the vertical direction and the horizontal direction. The convention is that all the forces resolving vertically, all forces up are taken to be positive, while all the forces down are taken to be negative. Now, while resolving horizontally, all the forces to the right are positive, forces to the left are negative. So you can just use these mnemonics that northeast is plus, southwest is southwest negative. So north is that is upwards and rightwards plus, downwards and westwards negative. That is number 2. Now the next convention is that to resolve an angle horizontally, if we have an angle, if we have a force of magnitude F acting at angle theta to the horizontal. Now this particular force is also having an upward or a vertical tendency, vertically upward action tendency. In that case, there's a particular component of this force which is acting upward, which we call the vertical component of the force, which is Fy. How do we get Fy? We can get Fy by considering this as a right angle triangle, in which we can say sine theta equals opposite, which is Fy over F hypotenuse. So in that case, Fy is now equals to F sine theta. F sine theta. So in that case, to resolve a force vertically, we make use of the product of that force and the sine of the angle it makes with the horizontal. Now let's look at the other component of the force, which is Fx. Fx is the total component of that force, which is this place. How do we get it? Let's take the cosine of that force. Cosine theta equals adjacent, which is Fx. Adjacent Fx over hypotenuse F. So that our Fx equals F cos theta. So that so take note. If you are resolving vertically, we make use of this sine theta. For resolving horizontally, we now make use of cos theta. Now applying all these conventions now, let's resolve these forces. Now the first component is vertical component, which is summation Fy, which is sum of all the forces vertically. We have the first force here is 20. 20 is upward, so it is plus. So plus 20 sine 40. The next force is 12. It's also up, so upward force. So plus 12 plus 12 sine 50. The next force is 10. So 10 is neither upward nor downward. Neither upward nor downward. So you can use any of the sign, whether plus or minus, which in any case is equal to have 0 as our answer for that particular, because this force 10 is purely horizontal. In that case, it's having no effect whatsoever with the upward movement. So let's just put it that way. So plus 10 sine 0. The next force is 15. So 15 is downwards, is below the horizontal line, this line. So minus 15 sine 60. The last force here is 16, which is downward. So minus 16. The angle between this is 90. 16 sine 90. Simplifying, we have 20 sine 40 is 0.6428 plus 12 sine 50 is 0.7660 plus sine 0 is 0 to 0. Now minus 15 sine 60 is 0.8660 minus sine 90 is 1. So simplifying this, everything now we will be having 0.86 plus 9.19 plus 0 minus 15 into 0. This will give us 4 Newton. That is downward force. So the resultant part of all the forces tends downward, since we have a negative number. Next, now we go to summation Fx, that is the resultant component of the forces. The first force here is 20. 20 is on the left side. This is the line on the left. So it's this side. So it's going to be negative. Minus 20 cos 40. 12 Newton is on the right. So it's plus. So plus 12 cos 50. The next one is 10 Newton. It's on the right too. So plus 10 cos 0. The next is 15. 15 is on the right. Look at the line. So 15 is on the right. So plus 15 cos 60. And then the last force is 16. So it can be plus or minus because it's neither left nor right. So this particular force has no effect horizontally because it is purely vertical. So plus 16 cos 90, 9 positive Newton. In that case, the resultant of the rotor part is tending rightwards. So in this case, now we now have a sum of vertical component of downward force of how many? Downward force of minus 6.94, and the resultant force of rightward force of 9.89. Now it's left for us now to resolve the two forces now into to get the resultant. The result of the force will be given by a diagonal taken from this point to give us the diagonal, the resultant. So this is our resultant. And the direction is given by this angle. Let's call this alpha. So to complete this into right angle triangle, and of course this side, sorry, there's no need of minus here. The direction has already shown the sign to go, so no point of putting the minus here. So this 6.94 is also displaced 6.94. So apply Pythagorean theory, we have that r squared equals 9.89 squared plus 6.94 all squared. So that will give us a total of 12.08. Now to get this direction will be given by the tan of this angle first. So tan alpha is equals opposite. The opposite is 6.94, and the adjacent is 9.89. So if we deal with that, we have 0.7017. So the alpha is given by the tan inverse of the results. 7017, and that will give us 35.06 degrees. What does that mean? It simply means that all these forces, 1, 2, 3, 4, is as good as having just one single force of magnitude 12.0 Newton acting at angle 35.06 degrees, 12.08 Newton at this angle. So the system here is as good as having something like this. Now, as a recap, the first thing we do is resolve all the forces into their vertical and horizontal components. After which we now apply our trigonometry to get the resultant and the direction of and the magnitude of the resultant. Thank you and see you in the next video. Alright, for more videos like this, kindly follow us on our social media platforms on Facebook and on YouTube. And if you find it difficult to in any science subject, be mathematics, chemistry, or physics, you may request for a private section where we'll be taking privately using the latest software and technology that will enable you to have something very close to real life physical class. Until then, see you. Thank you.